Hi guys, it's me Goknath here. So guys, today we're going to see Boyle's law, which is one of your gas laws. And guys, this Boyle's law was found by one scientist named Robert Boyle. And guys, let us see what does this Boyle's law say. So first, let me say there's an ideal gas. I'm saying that there's an ideal gas such that the temperature of that ideal gas is constant and it is a fixed amount of gas. I am saying that there is an ideal gas. There is an ideal gas and for that ideal gas the temperature is constant and even it is a fixed amount of gas. That means I am saying in terms of your number of moles. That means fixed amount of gas means fixed number of moles. I hope that makes you people clear. So there is an ideal gas such that temperature is constant and it is a fixed amount of gas. That means in terms of number of moles. So fixed amount of gas means fixed number of moles. Okay, this is what I am saying. So for that gas, Robert Boyle concluded that your pressure will be inversely proportional to volume. For that particular gas, which is in a manner of constant temperature and it is a fixed amount of gas, that means fixed number of moles. For that gas, Robert Boyle concluded that the pressure will be inversely proportional to volume. That is a statement which Robert Boyle had explained detailedly by the various experiments that he did. So what is the statement? The statement is your pressure, let me represent your pressure as P, that is inversely proportional to your volume. Okay, this is how we represent the inverse proportion, right? So P, which is pressure, is inversely proportional to your volume. This is what the statement which the Robert Boyle concluded by doing many experiments. So guys, we know that this is a statement. 1 minute. We know that this is a statement. Now what every people will do is, while seeing this proportionality symbol, they will try to take out this proportionality symbol and they will be putting in constant. Yes, indeed. That is what I am also going to do here. Because guys, it's kind of usual, right? Even you did in your Newton laws of gravitation, Newton's universal law of gravitation, and even your spring force, which is F is equal to kx, and even in your Coulomb's law, Coulomb force. So like that only, here also I am going to take this proportionality symbol and I am going to add a proportionality constant. Okay, so I am going to take this symbol, which is proportionality symbol, and going to add a proportionality constant. Very simple. Just I am going to add the constant just as you did in your Newton universal law of gravitation, the spring force like your F is equal to kx. That's what I am also going to do here. So when I take this proportionality symbol, what type of constant I am going to add is, I am going to add a constant called as k, which is p is equal to k into 1 by v. This is what the type of constant that I am putting here. So what I did, just I removed this proportionality symbol and wrote a constant here. That is what the step which I did. So 1 minute guys. So P is not writing well. Yes. Now, I just took out this proportionality symbol and I added a proportionality constant known as K. And this K is something which we call as your Boyle's constant. And this K, which is the proportionality constant, is something which we call as your Boyle's constant. So, your P is equal to K into 1 by V. And this K, that means your proportionality constant K, is what we call as your Boyle's constant. Why? Because this K is part of your Boyle's law only. Because from this relationship only we are saying we are taking this proportionality symbol and putting a constant K. So this statement belongs to Boyle only, Robert Boyle, because he only found that by the many experiments. Then of course he should keep the name as this K as your Boyle's constant, and that is what we are doing here. This is kind of obvious. This is a form of expression which Robert Boyle found. So K should be of course be the Boyle's constant. Okay guys, now tell me what will be the magnitude of this constant K? What will be the magnitude? The magnitude of this constant K will be nothing but P into V. Will be nothing but P into V. Just by this relationship I am saying. This Boyle's constant K, the magnitude of this Boyle constant K Boyle's constant K will be nothing but P into V. Very simple thing, just by solving the equation. Just by solving the equation. This K will be nothing but P into V, just cross multiplying. Very simple, na? If P is equal to K into 1 by 3, then your K will be nothing but PV. What is this K? Boyle's constant, as earlier I told. So this magnitude of Boyle's constant is P into V. Now this Boyle's constant, which is K, depends upon the temperature of the gas and even the amount of gas. That means fixed, and it should be a fixed amount of gas, and also it depends upon the pressure and volume. So this Boyle's constant, which is K, depends upon your temperature of that gas, which need to be a constant temperature, and even it depends upon the amount of gas. That means a fixed amount of gas. And also it depends upon your pressure and volume. I hope that makes you people clear. And guys, from this statement, from this relationship, you guys would say that for any gas, for any ideal gas which has your constant temperature and it is a fixed amount of gas. Fixed amount of gas means fixed number of moles. If it has a constant temperature and fixed amount of gas, then I would say that the product of your pressure and volume will be nothing but the product of your pressure and volume will be a constant, which is your Boyle's constant. From this relationship only saying, for any ideal gas which has constant temperature and it has a fixed amount of gas, then your product of your pressure and volume will be a constant. Okay, this is what you guys need to understand. And finally, what you need to know is, guys, it's a very simple thing only. So next I will say one example. Let me say there's an ideal gas such that the temperature is constant and it is a fixed amount of gas. Initially, the pressure of that gas is P1 and the volume of that gas is V1. Initially I'm saying. Initially the pressure of your pressure of that ideal gas is P1 and the volume of that ideal gas is V1, and some expansion is happening to that ideal gas. Okay, so that some expansion is happening to the ideal gas due to many processes, and the pressure is becoming as P2 and your volume is becoming as V2. This is what happening. So what I said is, there is an ideal gas such that it has high temperature and it is a fixed amount of gas, fixed number of moles. Now the initial pressure is P1, initial volume is V1. Now there is some expansion happening to that ideal gas due to many processes which you guys know already, correct na? In states of matter of your 11th chemistry you guys learned. So due to many processes there is some expansion happening, and that is the reason why P1 pressure changed to P2 and V1 volume changed to V2. Now here I can use your Boyle's law or not. Can I use Boyle's law here? Of course I can use here, because this ideal gas has a constant temperature and it is a fixed amount of gas, it is fixed number of moles. If it has both the conditions, then I would use the Boyle's law here. Using Boyle's law, I would say that this P1 V1 will be equal to P2 P2 will be equal to some constant K, and this constant K is your what? Constant K is your Boyle's constant, and that's all, guys. So what's the basic thing is, we know that your constant K, which is Boyle's constant, is equal to PV, and that's all I'm saying. P1 into V1, which is the initial state pressure P1, initial volume V1, the product of that will be also equal to P2 into V2, which is P2 into V2, and that will be equal to Boyle's constant, that will be constant. That is why I say, for any ideal gas which is constant temperature and what? Fixed amount of gas, fixed number of moles, then the product of your pressure and volume will be a constant. Even though any process happens, like your expansion, like your contraction, any process, you name it. So if any process happens, if your pressure changes, the volume changes, then of course what will happen? Then of course, all these values will be same. I hope that makes you people clear. So that's all, guys. P1 V1 will be equal to P2 V2, which will be a Boyle's constant, which is K. So that's all, guys. And finally, you will be playing with graphs. Okay, in Boyle's law, Charles law, Gay-Lussac law, Gay-Lussac law, Avogadro's law. You will be playing with graphs. So I will be doing in later sessions. But before that, I just taught you the concept which you guys need to know on Boyle's law. And this comes under chemistry and even your what? Physics. So that's all guys. Thank you. Make education simple.